Welcome back everyone, Patrick here. Moving on to the next video. What we have to do is find an equation for each of these parabolas here in standard form. So when they ask for the quadratic, which is what each of these are in standard form, they want it in this kind of format. However, notice the kind of characteristics that were given with these graphs. Notice that we're given the x-intercepts, and then we're given some other point that lies on the parabola. So here also x-intercepts, and then another point that lies on the parabola. So even though we're going to get it ultimately in standard form, what we want to do is, because we're given the x-intercepts here, we want to work first with the factored form. That's the easiest way to find an equation of these because we're given these x-intercepts. Remember, the x-intercepts come from these factors over here. And then we could solve for this a value by plugging in, once after we plugged in these factors, the x-intercepts into the factors, we could solve for the a value by plugging in that other point. And then the a value would be the only thing to solve for. So starting here, now if we have factors, so let's say we have a parabola like x minus 2x plus 4, right? How do we get the x-intercepts? Well, we find when does x minus 2 equal 0, when does x plus 4 equal 0, and so the x-intercept is going to be 2, and then here the x-intercept is going to be negative 4. And so what we want to do is go backwards. We've done a video before where we were given x-intercepts, we had to find the equation. Well, now this is sort of the same thing. It's just now the x-intercepts are given in a diagram. And so an x-intercept of 0, if a quadratic is going through that origin, we know that it's basically going to be x minus 0, and so that's just going to be x equaling 0. So there's just going to be a single factor of x because of this x-intercept. And then if we have a positive 7, an x-intercept of 7, well, when we bring it over, we end up with x minus 7 equaling 0. And so that's the other factor if we have an x-intercept of 7. We're just going backwards, right? So we have the other factor being x minus 7, right? If you just ignore this, ignore the diagram, if you're given something like this, what are the x-intercepts going to be? Well, it's going to be an x value of 0, and then when does x minus 7 equal 0? That happens when x is 7. Right? So now we're just going backwards. And so now that we have it in this format over here, notice the only thing that's left to solve for is this a value. And so what we could do is we could take this point 5 and 10, we could plug in 10 for y, we could plug in 5 for x, and then we can solve for this a value. So we'll have 10 over here. A will have 5 times negative 2. So we end up with negative 10a. Divide both sides by negative 10. So the a value is negative 1. Okay, so going back here, we have an a value of negative 1. So we could just put like a negative over here. We don't have to actually write the negative 1. And so that ends up being the factored form for this quadratic over here. We got the two intercepts, x is 0, x is 7, and then we have the a value of negative 1 in front. And so this is the factored form for this parabola, but we need it in standard form, so what we do is we just expand this. This is an easy expansion. It's not two brackets that are multiplying, so we just end up with negative x squared plus 7x. Okay, so that right there ends up being the equation for this parabola over here. And then you could test this. It's easy to see the intercepts, but then you could just test the points. So you could plug in, actually you could test any points. You could plug in 0, an x value of 0. Notice how you get a corresponding y value of 0. We could plug in a point 7 or an x value of 7. We'll have 7 squared, 49 times negative 1 is negative 49 plus 7 times 7. This is positive 49. Negative 49 plus 49 gives us 0. We could plug in 5. 5 to the power 2 is 25 times negative 1 is negative 25 plus 7 times 5 is 35. Negative 25 plus 35 gives us that y value of 10. So you could plug in all these points into the equation that you get to ensure that left side is equal to right side. So plug in the x values and get the corresponding y value that's there in that point. Okay, so you could always check your answers. Moving on to the next one. Notice here we have an x-intercept of -3, and then we have an x-intercept of +8. So what are the factors going to be? Well, we bring the -3 over, we bring the 8 over. So those right there are the two factors that we'd be working with in the factored form. We don't know the a value yet, but we do know the two factors, x plus 3, x minus 8. That's where these two x-intercepts come from. And so then if you want to solve for that a value, you can plug in 5, -16. So we plug in -16 for the y value. We plug in 5 for the x value. Just give me a sec here. Yes, and now we could solve for that a value. So we'd have a, 8, -3. So we have -16 equals, this ends up being -24a. Divide both sides by -24. And you'll have an a value of what? The negatives cancel out. 16 over 24, that simplifies to 2 over 3. Right? You could divide the numerator and the denominator by 8. So the a value in this case is 2 over 3. So going back to here, this a value is 2 over 3. But we can't leave it in this factored form. Remember, they want it in standard form. We get it in factored form initially because of the information that we're given, but then we convert it to standard form. So what we would do is expand all this. So when you FOIL it out, it ends up being x squared. You'll have -8x plus 3x, which gives us -5x. Minus 24, like that. And then you could distribute the 2 over 3, so you end up with 2 over 3x squared minus 5 times 2 over 3 gives us 10 over 3 x. This is like over 1, right? This 24 is like over 1. Negative 24 times 2 over 3 would give us -16, like that. And so that ends up being the standard form equation for this parabola over here, right? It's a little bit more complex because that a value is a fraction. And again, if you want to check your answer, you could take these points, plug them in. So if we plug in -3 for x, we'd end up with 2 over 3. -3 squared is 9 minus 10 over 3 times -3 minus 16. Let's see what we get here. So we'd have this, 2, so we'd have 4 over here. Or sorry, this should be 3. 3 times 2 is 6. 2 over 3 times 9 is 6. These 3's cancel out. Then we have a negative turning into a positive. That'd be 10. Then we got -16. Notice that we do get a corresponding y value of 0 as expected. Let's plug in 8. What would happen if we plug in 8 over here? We'd have 2 over 3. 8 squared is 64. Minus 10 over 3 times 8. Minus 16. I feel like this one's going to be a little bit more complex, so we'd end up with 128 over 3 minus 80 over 3. And then the 16 over 1, if we multiply the numerator and denominator by 3 to get a common denominator, we'd end up with 48 over 3. And this would give us 128 minus 80 minus 48 would give us 0 over 3, which would give us 0. So this point checks out. If we plug in a value of 8 for x, we get a corresponding y value of 0 as expected. And then let's check this point over here as well. Plugging in 5, so 5 to the power 2 is 25, minus 10 over 3 times 5, minus 16. So this would be 75 over, oh no, what am I doing? 50 over 3, minus this here would be 50 over 3 minus 16. These net out to 0, and you end up with that y value of -16. Okay, so whenever you get these equations here, you can take each of your points, plug in the x values, and make sure you get the corresponding y value.